Hussey. I'm the head of product management at DreamFactory. Thanks for joining today. Today with me is Johnny Kiram, MSV. Johnny is an analyst, advisor, and architect that covers the microservices space. I'm also joined by Ken Lane, the API evangelist, really an expert on APIs, and he knows a ton about the emerging microservices space. So welcome. Let's get started. So Johnny, if you could help the audience with the basics. For folks out there that are new to microservices or just getting started, what are microservices at a high level?
Sure, Ben. It's my pleasure to be a part of the panel. So let me kick this off by just introducing what are microservices to the audience. So microservices technically is not something very new. It's been around for a while in terms of the pattern, in terms of the architecture, but some of the factors like the rise of containers and API-driven development, followed by REST becoming more or less the de facto standard, encouraged developers to adopt this new paradigm. So basically, microservices is all about taking a pretty large application that used to get deployed in a typical application server or a typical execution environment and turning that into much more manageable, autonomous, smaller modules and packaging them as a set of containers and deploying them in an environment that is capable of managing these containerized applications. And container, when I say, I don't really mean Docker. Prior to Docker, I have seen some customers actually implement microservices using something like a Jetty container, which is very specific to JVM. It is essentially a container to run Java-based applications. So I have seen customers package their Java components as Jetty containers, deploying them and making them communicate with each other and updating one Jetty container at a time. So that was the actual prelude to containerized microservices. But with the availability of more manageable container infrastructure, something like Docker, and the rise of container orchestration management tools like Kubernetes, DCOS, and Docker Swarm, developers found an easier mechanism to take smaller chunks of code, package them as containers, as Docker containers, and run them on infrastructures like Kubernetes or Amazon EC2 container service and so on. Mm-hmm. So essentially, the idea is you take an application and break it down into logical modules that are completely autonomous, completely independent, and deploy them in an environment where they're all collectively managed. And the best thing about microservices is every service or every component is very independent, and it doesn't actually need to acknowledge the presence of other components. So, for example, an authentication component, what used to be a typical module or a library or a REST endpoint in a traditional environment, will be packaged as a microservice, and that is completely standalone. It's a black box that takes some kind of authentication inputs and then tells whether the user is authenticated or not. So that service can be reused and packaged and deployed in this new microservices environment and invoked, or rather utilize it from a set of other services. So that is essentially how microservices are evolving. It's a very new area, but the concept is taking a large application and breaking down into independent autonomous modules, packaging them in a more manageable form, and orchestrating them at runtime.
Great, that's an excellent introduction to microservices. I think really provided the kind of the foundation for what we're going to talk about over the course of the rest of the discussion today. So Ken, I have a question for you. Maybe you could tell us a little bit about what you're working on. You know, you work with a lot of companies that are using microservices, or maybe they're just starting out, you know, figuring their strategy with microservices. What are some of the sort of the common use cases you're seeing out there? And then maybe you could talk a little bit about when microservices can be advantageous versus, you know, this traditional, I'll call it, for lack of a better term, a kind of monolithic architecture I mean, surely microservices aren't for everything, but they clearly have great benefits for certain scenarios. Could you tell us a little bit about that?
Sure. I mean, I think Johnny covered pretty well that kind of technical undercurrent that's very much, as he said, it's been going on for a while, but I think really got expedited once, Amazon Web Services came out with EC2 in 2006, and then that continued to evolve with Docker and Kubernetes and what we're seeing. So all of that is very much I would say the technical undercurrent of microservices. While I pay attention to that, I really am interested in the top level, the business currents and flows that either make people think about microservices as a company or organization, but how they the why they're going to do it, how they're going to do it to meet business goals, rather than just the decoupling and the technical side is, companies started doing APIs, web APIs, and seeing very much 2005 to 2010 was really about kind of the business of APIs, and this first wave of API management providers came along, and then in 2010 this next wave that we have right now, which DreamFactory is one of them, is really how do you take your databases, your legacy internal monolith systems, and connect to them using gateways or connectors and various approaches, or all the way to just files, big huge XML dumps. And then how do you meter those and put those out? That's making sense of it from a provider standpoint. How do you put service composition in front of that, break those APIs up into different logical product groups? So you're thinking of these very technical resources in a very business way. How do we start unwinding, breaking these down, and coming up with products and things that we can sell to other partners and third party? So while that's going on, that's creating a certain amount of awareness with companies at the business level. And then as that's, in 2014 and 15, we started seeing the second wave of that's very consumer focused, not just provider focused, but the testing, the monitoring, understanding how these resources are being integrated with, and again, breaking things down, building awareness of what's flowing through the pipes, how they're being consumed, metering that, charging for that, but then having that feedback loop with customers to understand what can customers afford, what do they really need. This call is too big, there's too much information, I just need that little piece. And so this business level awareness is really driving companies to kind of step up and take notice of microservices. I think the front end is very kind of trendy. It's like microservices are very cool, we should be doing this. But then I think there's this larger, stronger current of companies that are like, hey, we've been building awareness about our digital resources and the bits and bytes we're doing business with on the web. How can we continue that cycle? And that's kind of what I see microservices as being.
Excellent. So in a sense, it sounds like it's really kind of the evolution, or the evolution continues, and microservices is just part of what companies have been building towards for a while. Does that sound kind of right?
Yeah, I mean, I definitely, I think it's, APIs are really the second wave of the web. We put all this stuff on the web and we're like, oh, there's all these ways to make money and do business. And then the second part is that, well, we got to do that across mobile apps, other devices, other system integrations. Right. APIs are that evolution. But now we have to kind of break that down into logical bits and bytes, and so that we can kind of orchestrate. I mean, you're doing think of an actual orchestra. You got lots of independent parts working together and many different groups. How do you logically lay that out? That's microservices.
Excellent. Okay, thanks. So Johnny, can we spend just a couple minutes maybe digging a little bit deeper into what's technically unique about microservices versus other computing architectures? I mean, specifically, what would you say are a few at least of the most important technical characteristics out there for any developers or architects listening? And what are kind of like the technical benefits of these attributes, would you say?
Absolutely. So the first thing that microservices brought is a very clean separation between stateless and stateful services. Thanks to the elasticity of cloud, for example, on EC2, we could very easily implement a scale-out architecture of web applications, assuming that we have moved away the state in terms of both cache, in terms of the database. And then we could technically scale out the web tier across multiple VMs and put that behind a load balancer. And that's how web scale has become more affordable for customers using the cloud. Microservices takes that to the next level because right from the initial design, there is a very clean separation between stateless and stateful services. So in microservices, even databases and very persistent stateful components are also going to be packaged as the same set of microservices. But that actually gives an opportunity to treat these two layers, the stateful layer and the stateless layer, separately, and think about how to actually scale the stateless tier very easily versus the stateful. And of course, stateful can be further clustered and can be brought into a HA mode. But the first advantage is a very clean separation between stateless and stateful. So architects who are actually refactoring existing monolith applications to microservices, the first boundary that they need to define is the stateless versus stateful. So that is a good starting point where they can start thinking about segregating them and then modularizing it further into a set of services. The second thumb rule, which is very important, is do not assume that your services are going to use shared libraries or SDKs. For example, if more than two services are using a similar library or a similar module or a similar component, that deserves to be a separate service by itself. So the idea is, don't repeat yourself. So don't basically bundle a set of reusable libraries across every microservice. If you are using it more than once, I think it's a great candidate to become a service by itself. So don't share any libraries or SDKs. That is another important thing, because we have this general tendency of installing the same set of libraries or modules or components in everything that we do. The advantage of microservices is, if you want to upgrade a library which is deployed as a service, you can selectively do that, and every other service, every other component, every other application that is consuming it will automatically get benefited from that. So do not share the libraries or SDKs. That is another important aspect. And focus on services with one task in mind. Basically what it means is, think of every service as a black box. It takes a set of parameters as input and either returns one value or sometimes even nothing. For example, if it is ingesting some data into a queue, just send the parameters and the service is going to be responsible for putting that on a queue and waits for the next request. So the idea is, one microservice does one thing and only one thing at a time. And that also aligns very well with the philosophy of containerization, where, for example, Docker encourages developers to package one service as one container. So if you are refactoring a LAMP application for microservices, for example, it's not a good idea to combine MySQL and PHP into one service. Instead, you should break it down into MySQL as one unit of deployment and your PHP plus Apache as another unit, right? And then you establish the runtime communication. So every service is supposed to do one task. And then in terms of communication, use a lightweight messaging protocol. There is a lot of debate on this, and I think Kim can add some color to it. There are a lot of new protocols that are emerging. Of course, REST is the most preferred and the most familiar protocol, but there are concerns around the performance of REST within the intra-service communication. So there are some new protocols emerging like gRPC and NATS, and I have seen some customers even implement Kafka for internal asynchronous and synchronous messaging. So use a lightweight messaging protocol that's most ideal for your use case. So these are some of the factors that I have covered in the white paper that we just published, and they would actually help the architects and developers who are making a transition from monoliths to microservices. Okay, great. That was really very helpful. Thank you. So Ken, Johnny talked a little bit about some of these technical benefits at a high level. Can you speak a little bit about how you see the business benefits? I mean, look, companies are just starting, many companies are just starting to transition to an API strategy in the first place. Are they really ready for microservices?
And what would you say the business pitch is? Say you're at a company and you're looking at this new architecture, or you're a developer. How do you kind of explain the business benefits to your boss, let's say? I think you're on mute, Ken.
Yep, sorry about that.
No worries.
Classic mistake. Haven't made that one in a while. But yeah, it's the business benefits are, really first and foremost, just thinking simply, looking at things, how do you break them down in all the technical areas that Johnny spoke of. And that's pretty diverse, as he said. It's not just the compute, it's not just the database, it's not just the DNS or the code or there's a lot. It's throughout the technical layer. And I like to look at API operations in 3 distinct layers. It's that bottom technical, the middle business layer, and then what I consider the politics of APIs, which can be terms of service, it can be regulations, it can be internal culture at your company. So very much you have to, I spoke a little bit about the business benefits of doing APIs, becoming aware of your resources, and then thinking of it from a API consumer standpoint with the API monitoring and testing we had. But that's really hitting the budget. If you're going to be doing APIs, you should be thinking about your budgets in small chunks. You should be thinking about your team sizes in small chunks. You should be looking at how you hire and build your team. Not that everyone should do one thing and do it well, but some team members should have microservice kind of reflect the microservices and do one thing, but some should be grouped across many different services with different skills. But you should be really dialing in your teams and your business approach similar to how you're doing it. And then same politically, if you're going to be selling this to your boss and making it work, you should be picking small projects. You should be picking things that you can do quickly, turn around, see results, get done, and show and demonstrate to your boss that this is making an impact and it's making change. And inversely, if you fail pretty quickly, and you can pick up and move on to the next project. So microservices isn't just about the technical; it's about the business and cultural implications. And then that just, that'll keep echoing and growing as you get more experience. So, I mean, API or microservices kind of way of life is not for all companies. Not all companies are ready for it. So even if you're super excited and your team's super excited, making it a company-wide, culture-wide thing is easier said than done. So, set the bar fairly low. Don't be disappointed, and start small and get incremental wins, because not every company's ready for thinking like this. And when you're looking at 10, 20, 30, up to 100 years of legacy technical debt to unwind, it's going to take some time. So just lay out a strategy, think through it thoughtfully, and get to work.
Great. That's excellent. Thanks for that insight. Johnny and Ken, both of you, just kind of digging into that idea a little bit deeper. I mean, so for practitioners out there, if you're an architect or a developer on a team, maybe you haven't moved forward with any projects that use microservices in the context that we've been describing, at least. I mean, how would you suggest that they get their feet wet? I mean, and show some early success. I mean, in practical ways, like what's a typical kind of project size, for example, knowing obviously this isn't universal. Team size, team roles, like what kind of sort of iteration speed would be typical. Testing processes. I mean, is there anything specific to microservices that you would recommend for practitioners out there that just want to get started with something and see how this technology works, but obviously get an early win with it?
Yeah, so I'll actually have Kin address some of this, because I read some of his work addressing the complexities involved in moving to the API first development, which obviously translates to microservices as well. But before that, there is a debate on what is the ideal size of a microservice and how many microservices should be composed into one application. So that's a classic question. That's a classic debate. And honestly, there is no thumb rule. There is no best practice for the size of every microservice, how fine-grained or how granular it got to be, and what is the average ideal size of microservices that can constitute one application. So it actually depends on two kinds of applications. The first one is, it could be a greenfield application where it is currently on the whiteboard, and you have the luxury of handpicking best of the breed technologies, languages, runtimes, tools, and whatnot. So you have plenty of room to handpick, what is the most ideal. So those are some projects, where you can maneuver the way you want and still deploy the application as microservices. The most complex part is refactoring existing applications, and that's where it becomes very challenging. Particularly, as I mentioned earlier, the demarcation between stateful and stateless becomes very tricky. And I have seen customers preferring to maintain stateful in virtual machines and conveniently move the stateless and the web front ends to microservices. And I think that's not a bad idea. It could be a pretty good transitionary path to becoming a full-blown microservices. I have also seen customers use managed services. For example, if the microservice deployment is on Amazon, they can tap into things like RDS, which is going to be a well-known endpoint, and all the services can keep talking to it. And that also relieves the architects and the ops from managing high availability cluster of databases, cache servers, and so on. So the easiest path is pick the stateless services, refactor them, and learn the best practices of containerization, and go ahead and deploy. So I think that is the shortest path to experiencing and benefiting from microservices. And once you understand the cycle and the benefits, then you can look at some of the other heavier components and more critical components that can also come into the microservices fold. I'll come back to it, but Kin, I'm pretty curious to hear your views about it.
Yeah, I think, as I said before, just get to work doing it. You can go into DreamFactory as a non-developer user, log in, create an account, and start playing with connecting to data sources, importing files, and just do that, start that API journey, as I call it, that many companies have been on for a while. Start, breaking down what the data is, what the content, what it is you're trying to decompose or decouple, even if it's a side project, if it's a just a piece of the big database, one table, one group, one use case. Just start somewhere. Keep this team small. Keep them, less than 5 people if you can. Make it a mix of people, not just developers. Like I said, business folk, and just tackle. I mean, obviously, as Johnny said, greenfield projects are easier to do, but we don't all have the luxury of greenfield projects. So legacy projects, problem area, find something that would be a quick win, solve a pain point. You could evangelize and spread the word that, hey, look, this is the potential of microservices. Keep the budget small. Keep it painless as far as the amount of money that's spent on this. And if you can keep it all small and nail it, you're gonna do well and be able to move on to the next one. Because remember, the goal isn't just one microservice here. It's going to be quite a few.
Great, thank you. That's really good information from both of you.
Ben, I just want to add a couple of points to what Kin said, and this is again more towards the best practices and some of the experiences. So I have seen developers choosing the most familiar language to develop microservices. There is nothing wrong with that approach, but I think one of the biggest benefits of switching to microservices is the ability to choose best of the breed languages, frameworks, and runtimes for architecting or developing services that are tailor-made for certain tasks. For example, if you want to expose sockets, you could actually package your microservices in Node.js and hide away the complexity or the runtime nitty-gritties from the consumers of your socket service. And similarly, when you're writing very tiny but heavy lifting components or services that are dealing with queues and processing some backend stuff, Go is a very good language. So I've seen many customers write these tiny services in Go and packaging them as microservices. So don't restrict yourself to what is most comfortable to you, because you would be actually doing a disservice to the overall maintainability and the deployment of the application. Instead, make sure that you are choosing the polyglot stack, as in choose what is most appropriate for that specific task rather than force fitting a language or a framework or runtime. So it's not a good idea to use JVM and JDK and Java for everything that you are packaging as microservices. Maybe certain components, certain services can be used or can be developed using Node.js or Go or Ruby on Rails. It all depends on what is the task cut out for and choosing the right tool. So prefer polyglot over single stack. That is something that I would recommend. The second thing is, one of the biggest advantages that I've seen customers gain by switching to microservices is the maintainability of services, which is basically versioning and maintaining different pipelines for these services. For example, you could have your CI/CD pipeline defined in such a way that you could technically upgrade one of the components through a canary release or a rolling upgrade with very minimal downtime. So if you have like a multi-service deployment and you are updating one tiny service, you can just upgrade or patch that service alone, and then build your CI/CD pipeline in the most effective way, where you are performing a rolling upgrade of just that component with minimal downtime. And that is one of the biggest benefits of switching to microservices. And again, not many companies take advantage of it, but I think to reap the complete benefit of switching to microservices, having that build management and revisions and CI/CD pipeline aligned with your microservices is very important.
Yeah, that's really interesting. I mean, a couple of those things, just to kind of summarize, this concept of specialization seems really important, right? So using the right programming language for the job, subject to, of course, having the right competence or programming experience for these various languages. And then also from a deployment perspective, that this idea of decoupling seems really important, in the fact that you can kind of mix and match these different microservices in various ways provides a ton of leverage. Of course, subject to what Ken was saying around the pragmatic aspects of getting the right projects, showing quick success, starting small, and then obviously in the end, no matter what, showing business benefit so that you can continue to do more projects with this technology.
Right.
Great. So this is great. So let me ask another question. I think microservices is definitely a really exciting technology, and in a way, I feel like we're really kind of just in the beginning. How do you guys see microservices evolving? Let's say over the next say couple of years. Would you say we're at the very beginning of the adoption curve? Specifically, let's say in the enterprise context, for example. And also, what do you guys see as exciting developments that are on the horizon, whether short term or even longer term?
Sure. Let me go first. So, as Kim mentioned earlier, we are currently in the fourth wave of computing. So the first wave was all about physical computing and client server dealing with bare metal. The second wave was all about virtualization, and that's where we had EC2 and the whole IaaS wave. The third wave of computing hit us in the form of containers, and we are just about to get started with the fourth wave of computing, which is serverless. The future of microservices is going to be serverless. In fact, I would actually call that as nanoservices, because microservices are still dealing with the packaging and deployment aspect. The debate is around, should I package it as a Docker container or a Rocket container or an OCI compliant container? And should I run it in Mesosphere? Should I run it in Docker Swarm? So there are a lot of choices to be made. There are a lot of decisions to be made. But the way the industry is evolving is completely based on serverless and no ops. So if a developer is writing a black box service, it is just a code snippet. So serverless brings a paradigm where the developer would never have to worry about actual packaging and deployment and scaling. He would write a snippet of code the way he would write a function and performs unit tests on it. But then he takes it to a runtime like Lambda or Azure Functions or OpenWhisk and runs it there. So a collection of such functions acting together to perform one end-to-end logical workflow actually translates to an app. And that is a very, very interesting development, because there are no servers to manage, no containers to deploy, no sliders to drag to scale. And of course, APIs become super important, because all these functions that are deployed in a serverless environment are going to be accessible to the outside world only through an API gateway. So that's the reason why there has been a tremendous interest in creating API gateways. For example, AWS has one, and Google acquired APG. Microsoft acquired a company called Epiphany, and now they are front-ending that with Azure Functions. So the bottom line is, the fourth wave of computing, which is serverless, will be the logical context where the microservices paradigm will eventually land. And Kin, I am again very curious to hear your thoughts on this.
Yeah, no, in agreement on the phases of computing. I would say for me the most important and significant aspect of microservices over the next few years that's going to make the biggest impact is just the continued wave of businesses coming on board with first their API journey, and then reaching the point where they can actually start doing microservices. And this is, everyday mainstream companies that are the bread and butter of our markets and economies around the world, serving everyone. So them getting on this journey and doing this is the most important piece of what's going to come out of that. That awareness at the management level, the awareness at the testing level, and when we can get to the point where every one of these decoupled components are running in its own, functionized, containerized environment, and it can be a bullet, on a API contract that is set with a certain amount of testing and assertions, meeting a certain SLA, a certain business objective. And when that can be done, when you have an API contract with 500 to 1,000 line items, and all of those line items work in concert to deliver a specific business goal or drive a certain industry, when we're able to do it at that granular level, that's where we're really going to start seeing shifts in the economy, how the world works as far as the internet. That's the most significant, I would say, the most exciting aspect of the changes that are coming from a technical are going to be very much algorithmic microservices. So we're seeing this with machine learning, cognitive, pick your buzzword, but really it's about one single unit of compute that does something. It's an image model, it's a video, it's a financial, data analysis microservice. But these algorithmic units of compute, not just being able to be deployed and scaled like this, that serverless affords us, but it can happen on our phones and our devices. You see Google doing TensorFlow on the phone. You see Apple making moves into this. So we're talking about, algorithmic microservices wherever you need them on device, not just mobile phones, but think Internet of Things. That's definitely, we got a long ways before that's really matures. That's a long road. But that's the exciting one. I would say the business and economic impact of this over the next decade is really where this is going to matter, or not.
Yeah, that's really interesting. I mean, this sort of idea of this combinatorial value of having microservices and being able to use them in combination is exciting.
Yeah, so, well, when you can have an API contract that could be fulfilled by multiple providers, offering the same consistent service, different levels of reliability, stability, privacy, security, a lot of those political things come into play.
Very interesting. So great. So I think we've hopefully provided a really good primer in the last 35 minutes or so. A question for both Johnny and Ken, for folks listening to this who are interested in maybe digging a bit deeper into the world of microservices, what resources would you recommend? I mean, whether websites, papers, books, anything else that you think would be helpful to people?
Yeah, so obviously I would like to announce the availability of the paper that I wrote, got reviewed by Kin. So there is There is this white paper on exploring microservices for web scale workloads. So that's available on DreamFactory. That's one of the starting points. And of course, I'm a big fan of Chris Richardson's microservices.io. It's a collection of patterns and best practices, and one of the best resources available on the web. There is a book by Sam Newman on microservices that's been very helpful for me when I was working with customers and when I was making the transition myself. And of course, the Bible of microservices, the very first article that triggered the whole debate, the microservices article, or rather a very forward-looking viewpoint from Martin Fowler, available on martinfowler.com. So those are the resources that I would love to recommend.
Great. Ken, what ideas do you have for people?
Yeah, definitely second the Martin Fowler's. I mean, start there because it's the origin story. But really, I have to just say, get started, get your hands dirty, because the real story, the real learning is going to come from you just thinking in a microservices way and connecting to that data source and start playing with API design and get going on that lifecycle kind of journey. So really the doing is the most important part, because no matter how much of it you read, no matter what tools you use, if you're not working with your resources and dealing with your business, political, internal culture, you're not gonna know how to approach this. That's where I recommend just getting going.
So yeah, get into it, learn, make some mistakes, learn from those mistakes, keep going in a way.
Yeah, starting a safe project. I mean, that's what I'm not to keep plugging DreamFactory, but that's what we're on a call here is you don't have to be a developer to get in there and connect to a data source and start playing and start seeing how it works. So pick low-hanging fruit, as I call it, safe data, safe content that you're not going to get in trouble, and play, because it'll definitely come into more focus.
Great. Thank you. So I just want to point out a couple of other things before we wrap up. Definitely, as Johnny said, please check out the microservices white paper. You can find that on our homepage at www.dreamfactory.com. That paper covers a lot of what we've talked about today. It includes quite a bit of information about how DreamFactory can actually help developers or architects implement a microservices strategy. For people not familiar with DreamFactory, just very briefly, it's an open source Apache license. We call it a REST API platform. It's basically a runtime middleware platform, essentially a LAMP stack. It really automates, as Ken was mentioning, the API creation for lots of different data sources. It could be SQL, NoSQL, file systems, and a whole lot more. And with respect to microservices, DreamFactory provides a really nice scripting engine for implementing microservices logic, which it's in terms of the persistence layer would be tied to different data sources, maybe a SQL database, NoSQL, provide a lot of support for many different databases. The product has a lot of modern deployment options. You can deploy with Docker, containers, Kubernetes, and even things like Swarm and Apache Mesos. So we talk a bit about that in the paper, but really, as Ken was saying, the key thing is find technologies. There are tons of great open source technologies out there that you can put together very, very quickly without very much of a learning curve to get started with just APIs, or as you learn about APIs or you're extending your API strategy with microservices. So just one more question for you guys. Where can people find both of you on the web, Twitter, your website, everywhere else, anywhere else rather that you might be?
I'm at janikiram.com, janikiram.com.
And I'm pretty easy with API Evangelist, apievangelist.com, and API Evangelist on Twitter.
Great, awesome. Thanks everyone for joining today, and thank you very much, Johnny and Ken, for your insights on microservices. And good luck with your projects, and get out there and start doing it. Thanks everyone.
Thank you guys.
Thank you.